And now we're live. Hello, everybody, and welcome to Business Data Analytics UK. Today, we're going to be talking about SQL. We have our lovely guest, Bukola Olafenwa, that's going to actually talk to us about creating outer joins. And then she's going to actually do like a live demonstration where she'll be doing the coding. And like I said, she will make it interactive so that you'll be free to ask questions and she'll be there to answer your questions directly. And for those of us has joined in the meetup, we're going to actually send you the presentation, the coding and the actual database, and a few examples as well, so you can actually try out the coding yourself and do some extra work. So you can test your understanding. Okay, so I think now is a good time to start. So would you like to take it away, Bukola, and then you can introduce yourself and then start the session.
Okay. Hello, everyone. It's amazing to be here again. Before I say anything else, please let me share my screen. Okay, come in. Yeah, good. So, hello, everyone, one more time. Yeah, it's another lovely, amazing online session. And this is actually my third. Yeah, the first on introduction to views, the second on writing SQL inner joins. And it is my utmost pleasure to discuss writing SQL outer joins today. Yeah, I am an academic mentor at the Letter Trust in London. Bukola Olafenwa is the name again. And today in my presentation, I'm going to be doing a brief reminder on what makes a join, the types of join that we have, especially the ones we focus on in the presentation. And then today, because we are highlighting the outer join, we're going to discuss the types of outer join in depth. And I'm going to introduce to you the syntax for writing the types of outer joins that we have identified. After which, I'm going to do a live illustration of how to write outer joins using various examples. And definitely, we're going to have a summary of what the presentation has been all about at the end of the session. So let's go straight to business because it's 10 minutes past 8 already. In the previous session, I discussed what a join was. And there, I think we discussed what a join is in terms of linking, connecting tables together. It is a data analytical operation involving retrieving data from fields of two or more tables in a single query. Now, using the categories and products tables as an example, these are two tables. We might need to get information, data that are distinct to both tables in a single query. When we want to do that, for example, maybe we want to get the category name from the categories table and the products name from the products table. To do that, we need, in a single query altogether, we need a join that will join both tables together. And both tables can be joined based on a common or related field. If we look at this critically, we will, scroll off again. If we look at it critically, we would see that there is a field that is common to both tables. We have the category ID, primary key in the categories table, and its foreign key counterpart in the products table. On this basis, we could link both tables. We could connect them. We could join both tables. And then aliasing is a very, very significant factor. All factors are significant, they're equally significant. Aliasing is one interesting aspect. I would like to throw it to the audience now, if anyone is willing to share if they have used aliasing in joins and how maybe how it has helped them in writing successful joins. I'll be very happy if anyone could share with us. So if no one is, Margaret, can you hear me?
Yes.
I
Okay.
wanted to talk, but
Okay.
I didn't find the hands up option.
Okay. Yeah, you could just
Yeah.
signify with your voice, please, and then just come on and share with us. We are willing to hear.
Hey, I don't know if my explanation is complete or not, but from my experience writing SQL queries, aliases are uh, being used to assign a new name for uh, basically a table, but this table can be our existing tables in database, like you're assigning a new name to uh, database name dot table, so we can distinguish it better from other tables who might
Yes.
be the same name in other database or something. Schema, I mean. And it can be also, and it should be, where we when we are writing SQL, we should use an alias for the tables that are being generated during the execution of our query. Like when we are joining two tables and we are creating a new table during execution, we should assign an alias to it.
Okay.
Yeah.
Okay. Right. If I understand what you just said, Alex, thank you so much. I really appreciate that contribution. It's about qualifying. You've even taken it to a higher level. We are limiting aliasing to the level of qualifying table names by field names and table names by their shortened forms, because we are just highlighting joins. Yeah, it is possible to alias table names with the database name. Yeah, it is very, very possible. And it's fine, but today we don't need to go that high. So, but then it's fine when we have column lists, we have fields from different tables, especially in tables where, for example, the categories and products ID tables that I have here. If you look at them, they have one field in common. You can call it field or column, just it can be used interchangeably. So the category ID, if we want to reference it in our column list, in our field list, and we do not qualify it but with the table name from which we have, extracted it, if we are to extract the data, is going to return an error, is going to cause an exception. So that is why it is good for us to alias, because with aliasing, we are rest assured that our joins will come out fine. Today, we are going to do more of aliasing, and it's going to be, a more enlightening experience. So,
we also have another person that has raised their hand. Precious
okay.
has raised.
Okay.
Precious, you want to unmute? Yeah.
Hi, thank you so much. Just to point out something, I noticed something. So when I see the primary keys under categories and products, there's category ID. Can there be an instance whereby, let's say we don't have category ID under products? Can we link those primary keys together? Can we link maybe an ID from categories to maybe supplier ID if category ID is not under products? Please, you understand my question?
Yes, I do. Yeah,
Thank you so much.
Yeah, you're welcome. You're welcome, Precious. Thank you so much for this question too. It's something that would, enable us to go deeper into the concept of keys. In the creation of database, when you create a database, you populate the database with data. And then in doing so, we do it in a structured way. Now, to do it in a structured way, to have structured data, we need to have tables. And then in the tables, we have columns or fields. And then we also have rows or records, whichever you wish to call it. So in the process of creating tables, we specify data types. Now, the data types now, okay, we say, okay, with the name of each field, of each column, and then their data type. Now, the category ID in the categories table here is unique. It's unique in the sense that it's the table's primary key. It is the one that is the major identifier of it's the major identifier of every other data because it's associated with every other data in the categories table. So here is the primary key. So, but it occurs, we have it also in the products table because in the process of trying to, populate the database with data, because this is actually my sample project, I reference the category ID in the products table as a foreign key. Now, it is about creating a relational database. Now, I've created these two tables in such a way that they are related to one another, to each other. Now, and that category ID is what establishes the relationship between both tables. Now, because the category ID in the categories table is the primary key, it is the parent table. We refer to it as the parent table. I try as much as possible to use everyday language when I'm doing my presentation so that it will be explicit to everyone. So now, we can have more than one child table. So for every parent table, there can be child table or children table. Now, this is the products table is a child table, child to categories, because it references, it has the category ID field that establishes a connection with the categories table. The category ID, the categories table is the primary key, and then this is the foreign key. If Precious, if you are familiar with creation of database, you should understand all of this already. So this is the foreign key. And as I've said, it is now possible. It's possible. In the suppliers table, I might decide to create another foreign key, a foreign category ID key that will also, establish a relationship between the suppliers table and the categories table. Yes, it is fine. It is okay. It depends on how you decide to structure your database. So it is possible. And, for you to understand the basis of it, that is why I have started with, the in-depth analysis of the process of the creation of database. So it is possible to have a category ID in the suppliers table. And I think in this database, we have even the sales table. If I want the category ID in the sales table, I can include it there. But there can only be one primary key, and that is the one in the parent table, which is the categories table, because it's the unique identifier of every data in the categories table. But the moment you could have one child table, like we have products that has one foreign category ID key, or you could have more than one, it is very possible and it's acceptable. It's appropriate, it's fine. It's just about establishing relations between the tables that constitute a database. Hope I've been able to to answer the question, in a very, very basic way.
Yes, you did. Honestly, even the terminologies you used were really understandable. So thank you so much for that. You answered my question, so I get it now. Thank you.
You're welcome. Yeah. Any other question?
No, that's it.
Okay. So thank you, Alex. Thank you, Precious. Yeah, that was engaging. So Elias then will do more of it as we go on. Yeah, and it seems okay. Now, the types of joins. Yeah, we have discussed the inner join that returns records that have matching values in both tables. And it is important to note that in an inner join of two tables, for example, there is a table on the left, there is another on the right. And then what the inner does is that it only returns records that have matching values in both tables. That is the inner join. So the second type of join is the outer join. So the outer join can be left, can be right, or full. For the sake of this presentation, we're going to be restricting ourselves to the left and the right outer joins. So the left outer join returns all records from the left table and the match records from the right table. Now, let us, that word left, let's keep it in our palms, left. Now we have two tables. One will be on the left and the other will be on the right. But now we have to make sure that the one we are going to position on the left is the one from which we want to return all records. And the one that will be on the right will be the one that we just need matched records from. You will understand as we, go further in the presentation if you are confused about the concept now. Another is the right. Now, the right join, the word right is the same, it makes sense, just like the left. Now, reverse is the case with the right. Unlike the left, where you position the table from which you want to return all records on the left, if it's the right outer join, then you have to position that table from which you want to return all records on the right. And the one from which you want just matched records, you place it on the left. Now, for full outer join, it is not supported in MySQL, but there's an alternative, the union and the union all keyword commands, but that is not our priority for today. So I think maybe in subsequent sessions, we're going to major on that. But there's one thing I need to say again about left and right joins before I move ahead, and that is that left and right joins, they return unmatched records as null values. Now, when, for example, the left outer join, when we return all records from the left and matched records from the right table, definitely there will be unmatched records because not all records can be matched in both tables. Such unmatched records will be represented as null values in left and right joins. If you don't understand it now, don't worry, you understand as we move on. So our focus is on left and right joins today. And if you notice, I have the word outer in parentheses, meaning that it is optional. We can just, if we want to write our left joins, we want to write our right joins, we can just say left join or right join. Or if we have the time, you can write left outer join, right outer join, but it is not compulsory. You have to add the outer. It is optional. You can just simply say left join, right join, and we are good to go. So let's discuss the syntax for writing the left join. Just like the inner join, you select your column lists. Column lists can also be called field lists. So you select a field list from the first table. Remember, this is a left join. And that first table, which is going to be on the left, will be that table from which we want to return all records. Then, from the table on the left, followed by the left outer join or left join command, followed and then by the second table, the table that will be on the right. Both tables will now be joined on the condition that both tables have a common field. They have a common column. Now, both tables, for example, the categories and products table. Now, if we are to use them as an example now, they will be joined on the condition that the category ID field in the categories table equals the category ID field in the products table. So that is how it works. There is always more than one way of doing things. That is my catchphrase in data analysis, because just as you can use on command, you can also use using. And that even is easier. You just write the using, and then the column or the field that is common to both tables, you indicate them in parentheses, and you are good to go. You get your result set. But I've once highlighted that the only command is better, is the safest command to use, because it works irrespective of whether the column that is common to both tables have the same name. In this case, for categories and products, they have the same name. It's category ID in the categories table, and you check the products table, it's also category ID. But there are some instances where you can just see the category ID in the categories table can just be labeled ID. And then in the products, you now have category ID. So one is named ID, the other category ID. If you use using, then which one are you going to pick? Are you going to pick ID or are you going to pick category ID, this is where on comes in. On accommodates such situations. So that is why it is recommended as the safest command to use for joining tables in a query. So just as the left join, the right join too, the same syntax, but what changes is the keyword. Left is replaced with right. And this is followed by a reversal of the table order. When we write a left join, it is possible for us to rewrite it using a right join. What we have written as a left join, note that it is possible to rewrite it as a right join and it will return the same result set, but on the condition that we reverse the table order. That table from which we want to retrieve all records that was on the left, when we used a left join, the moment we use a right join, we move it to the right. And then the one on the right moves to the left. And then our result set become a fine. And both tables too, in a right join, can also be a linked, connected join based on a column that is common to both of them. And just as you can use the on command in a right join, you can also use the using when the column that is common to both tables have the same name in both tables. So this is a lot to take in, I know, but it's nothing, it's not that complex, it's nothing serious. And I'm almost at the point of going into, doing live demonstrations of how to write these joins. So you find it easy and you understand every concept as we move forward. Now, this is a sample relational database from which I've called the categories and products table earlier. Is a database of 5 tables. The one I did for my data and SQL project for Code First Girls is on GitHub, and I think we've shared it previously in previous sessions, and I hope it will be shared again, maybe after this session or any other time. And this is comes handy. I've modified it in a way that it should be appropriate to answer questions relating to left and right joins in today's presentation. So, without wasting time, let's just go right into writing some left and right joins. Yeah, we have a first question here, and the question is saying we should retrieve the ID, name, weight, and sales amount of all products, including products that have not been sold. And we are going to, write a query using a left join. So I'm going straight to my MySQL workbench where I'm going to start. Oh man. Okay, good. First, I'm going to activate the database. I have it in my schema already. The name of the database is Express Grocery. Okay, yeah, execute it. It works fine. And a question says we should retrieve the ID, the name, weight, and sales amount of sales amount of products. Okay. Okay. So for the typo there. Okay, let me go back to the question. Including products that have not been sold. Okay. That have not been sold. Good. Now, we are starting with left join. Yeah. Let's look at this question closely. There we already see, we can guess our column lists, what it would contain, the ID of the product, the name of the product, and then the weight of the product, as well as the sales amount of the product. That is each sales record, including products that have not been sold. So what this question is really telling us that the data of all products, including those that have been sold and those that have not been sold. Now, let's write a select statement. And before we do that, I always say it in every session. We don't just go ahead and begin to write, oh, select ID, name. Let me just try that. And then I just say wait. And then I just write sales amount. No, that is not how to do it because it will return an error. We have to be sure that this is exactly the way these fields have been named in their various tables. Now, we have the products table to query, and we also have the sales table to query because it's not only about the products, but it's also about the sales of the products. So now let's go to the products table. Let me open directly the schema. So what do we have here? Just remove this. There's something here. Okay, good. So here in the products table, we erase this. We have the product ID. As you can see, it is not written ID, it is written as product ID. So if we go ahead to just write ID, the query would not recognize the field we are trying to refer to in the products table. So also the name, it is product underscore name. And then weight is weight. And then when we go to the sales table, we look at sales amount. How is it referenced? Sales underscore amount. It's only when we reference them according to this way that they have been named that our code can work. So now we have to correct ourselves. What we have is product ID, and then followed by the product name, and then followed by the weight, and then followed by the sales underscore amount. Very good. From now, this question is telling us to get the data of all products, including those that have been sold and those that have not been sold. That means we need all records of the ID, name, and weight of products from the products table. Since we are using a left join, that means the products table from which we are going to obtain all records will be on the left because we are using a left join. And I'm aliasing this table name by its shortened form P for easy reference. From products as P, left outer join. Let me use the outer, the optional keyword as in this start. Left outer join the sales table. Sales table will also alias as S. And what's this? And then both tables will be joined on. Yeah, let's check. We have a product ID in the products table as a primary key. Let's say if it has a foreign key counterpart in the sales table. Oh, yes, it does. So we're going to join both tables on this common product ID field in both tables. So we're going to product ID. So we're going to join them on the condition that the product ID in the product table, because we have aliased it, equals the product ID in the sales table. Now, I don't know. I think at this point, I want it to be very engaging today. I want a very interactive session. I really need someone to tell me, is it okay now? I should just run the code. It's going to work well. Or have you noticed anything not okay with the way I've written this code? If you've noticed anything, what exactly is wrong? I would appreciate contributions from the audience.
Can everyone see the screen?
Huh?
Can everyone see the coding properly to be able to tell what's wrong with the code?
Yeah, maybe it's right. Maybe nothing is wrong. or maybe something is wrong. And if that person sees something wrong, what exactly is wrong? Okay. I think at this point, I just have to continue and then say what exactly is wrong. As I said, now they have a common field, and that's the product ID. There's something we have failed to do here. We have failed to specify. In our column list, we have this common product ID field. From which table are we referencing it from? Is it from the products table or from the sales table? We have failed to specify. As a result, if I run this code, let's see, it's not going to work. You can see it saying column product ID in field list is ambiguous. It's saying, oh, you have a field in this list that is common to both tables, but hey, you have failed to tell us it's in both tables. Choose one table, take it from one table and specify that it is from this table. So in that case, it's always safe to alias your column list to avoid issues like this. So we take the product ID from the products table. Remember, I've alias product as P. We take the product name for the products table. We take the weight from the products table. And then we take the sales amount from the sales table. And now let's run our code. Now it works. Now, I want you to look at this result set. I want you to look at it very, very well. The result set says a lot, tells us a lot. Yeah, we have a result set for goods, products that have been sold, as well as those that have not been sold. And if you notice, you see null, null, null. The null values represent the sales values for products that have not been sold. The null means they have not been sold. Assorted meat, for example, not sold. That's why it's null. And this one sold, sold, sold. French fries, not sold. So we have a null value. Jacket potato, not sold. So we have a null value. And so on and so forth. So this is what a left join does for us. It takes all records from the products table, matching records, that is those with sales from the sales table, and also returns unmatched records, those that have not been sold with null values. So that is all on that. Now, we have used the on command to join both tables. Let's use the using command now. Let's experiment with it just this once. Remember, I say using followed by the
Sorry, Bukola. We have a question from Precious.
Okay. What question?
Thank you, Bukola. Yeah, I'm so sorry for taking you back. Just looking at the question, how were you able to know that you were supposed to use a left join concerning this? I understand that you gave us like visualization showing circles and with inner joints, with inner joints there's an intersection, and with left join and all of that. But from the question, how were you able to deduce that we're supposed to use a left outer join for this? Because the way the question looks like, I would have gone for an inner join instead. Can you expand on that? Yes.
Exactly. Good. The previous session was about inner joins. I don't know if you participated. So, there's a reason why that is inner and the reason why this is left. Now, the inner join will only return matched records. Now, let me use the inner join. Inner join. Let me show you the result set again so that you can see it. As you can see, we have null for goods, for products that are not sold. So let's try inner. The inner join. Now, let's look at our result set. Now, okay. There's something I need to do here because the inner join is kind of, let's order by product ID so that it would automatically be okay. Now let me rerun the code. Very good. Now, as you can see, because I order it, so it's ordered 1, 2, and like that. Now, let's look at it. Let me scroll up, 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 up. Good. It really works, showing areas where there are no sales and where there are sales. But believe me, there are instances for you. Wait, no, I'm missing the left outer join. It's not supposed to break. Wait, okay, good. This is the inner join. Sorry, I reloaded the left outer join. Good, very good. I was confused because it's not supposed to give us that. Good. Now this is the inner join. Let me also order it. Order by product ID so that it can be neat. Yeah. Good. Now let's scroll down. Let me try to, yeah, this is kind of confusing. As you can see, this is the inner join. So now let's try to scroll to the result set. No null values. No null values. What that suggests is it has only given us a result set of matching records. The inner join can only give us a result set of products that have matching records in the sales table. Products that have not been sold, they have no business on the sales table. I think you understand that. So an inner join will only give us the result set for products that have been sold. But what the left join does is that it returns a result set that shows us both products that have been sold and those that have not been sold. Here, it lists unsold products. Assorted meat is a product, but not sold. This kind of information is required when a grocery store, when they want to take account of products that have been sold. Okay, we have social sales. Okay, which products have been sold? Which products have not been sold at all? The left join is very, very useful to retrieve such data. So now the difference between the inner and the left is that the left join will return the result set for all products, both those sold and unsold, and it will distinguish that, oh, this is sold and this is the sales amount. But this is not sold, and then represent what should have been the sales amount as a null value, meaning that the sales amount is lacking. We do not have a sales amount value for that product. But if it is inner will just give you, matching records of products that also have matched records on the sales table. I hope you understand it now. As you can see, this is inner, no values. So this is just for products that have been sold. But for the left outer, it will give you information about both those that have been sold and those that have not been sold. Hope it's clear to you now.
Yes, it is. Thank you so much. So I understand that the inner join gives you like an intersection between both tables.
Exactly.
And then the outer join, the left outer join now gives you all encompassing. I understand that. Thank you so much.
Exactly. I like that summary. It's just art. So that is it. So moving on, we have experimented with the left join. So we can rewrite this same join to return the same result set using a right join. What we'll have to do is that we just have to, I'm coming using right join equivalent. We have this here. The left keyword we change to right. And when it changes to right, remember I said there will be a reversal of the table order. Before it was the left join, so we wanted to retrieve all data from the left table. So now because it's a right join, that table from which we want to retrieve all records must move to the right. So we're going to have the sales here. The sales go to the left because all we need from the sales is just matching records. And then the products move to the right where we need all records. And then we rerun our code. I don't need the order by. That was for the inner join. I don't think I really need it to order. Good. So here now, we have the same result set. And let's go down, down, down. We have the null values. Remember, assorted meat, not sold. French fries, not sold. Jacket potatoes, not sold. In that order. So with that, we are able to get our result set. So now let's move on. Let's one more question on the right join and the left join because time is not on our side this evening. Let's move on. Let's take this. Salesperson ID and their corresponding total sales, including salespersons who haven't made any sales. Salesperson ID and corresponding total sales. Salesperson's ID and corresponding total sales, including salespersons who have not made any sales. Good. Now we're talking about salespersons and we're talking about sales. That means we need information from the salespersons and sales table. Fine. Now we need to go to the salespersons table. How is the ID reference in the salespersons table? It is referenced as salesperson ID. So we just come here and write a select statement. A column list will be the salesperson table. I'm going to alias it as SA, salesperson ID. Now, and then corresponding total sales. Now, we are not dealing with individual records, unlike what we did in the first individual sales records. No, what we are trying to do now is we want the salespersons over time of each salesperson. So we're going to use a set function, otherwise known as an aggregate function. And this time around, we're going to use the sum function. Sum of distinct sales. Here with sales amount, sales underscore amount. And I'm going to alias this as total sales from, as usual, we're going to use a left join. And we want information for salespersons, what those that have made sales and those that may not have made any sales. So that means we want all records of the salesperson's ID from the salesperson's table. So, and we're using the left join, the salesperson's table will be on the left. Salesperson as SA, left join, the sales as S. On, I'm going to join both tables on. Let me check. The salesperson's table, there's a salesperson ID. Let's start with that first information. Oh, good. The sales table, we also have a salesperson ID. So let's go straight to the point. On joining them on the condition that the salesperson ID in the salesperson's table equals the salesperson ID in the sales table. And it does not end there because we have used a set function. We have to group our results and we group by the salesperson ID. And then we try to run our query and then we get a result set. Now, we have 4 salespersons, So let's go to the salesperson's table. Yeah, we have 4. Abdul, Julie, Femi, and Scott, 4 of them. And then we have a result set giving us information about the 4 salespersons. The first salesperson, the salesperson ID1, had a total sales of £427, 10p. The second, 236.98. The third, 477.43. Unfortunately, the fourth has never made any sales. So, because there is no sale for the salesperson has made no sales, it is represented with a null value. This is what a left join will do. Now, we can write the same code using the right join equivalent. The only thing is that the table order will be reversed and then the keyword changes. So let's just copy here. Comment. Where? Okay. Where? Oh, I've copied the wrong code. I think I need to bring this down. It's really confusing me. You're very good. Now I can see better. Now we just have to copy this and then rewrite the right join equivalent. Now the right join equivalent, to write it, the left keyword will change to right, and then the table order will be reversed. We have a sales as S and salespersons, from which we want all records to be returned as SA, and then we run again, we get the same result set. Let me erase it. We get the same result set. Now, we have been coding using, using joins based on one condition. I want to write a query that will be based on 2 conditions. Now, there is a question. Yeah, supplier names of all products with ID greater than 20. Supplier names of products with ID greater than 20. Now, we have to deal with suppliers table and the products table. Now, let's open the suppliers table right from the schema. Now we have the supplier ID, good. And then when we check products, I want us to check products to see if there is a common field before we start writing. Yeah, we have a supplier ID foreign key in the products table. So let's just move on. Now, select supplier names of products with ID greater than 20. I think it's appropriate we start with products ID, and I'm aliasing the products table with P. Okay. And then the supplier name. And I'm going to alias the suppliers table as SU from. Now, We want supplier names of products with ID greater than 20. And one thing is that I think I need to add it here. We're going to include names of, okay, let me write it and then you understand. Let me first of all run the code. Yeah, to make it explicit. Now, from the suppliers table, some suppliers as SU, the left join, products as P. Now, and both tables will be joined on the condition that the products ID, not the product ID, sorry. Let's check again. Both have the supplier ID. They have the supplier ID. Let me run the products table again. Yeah, both have the supplier ID rather. We'll be using product ID. So the supplier ID, the suppliers table, equals supplier ID in the products table. Now, there is more than one condition. We want to return a result set on the condition that we are joining the tables based on a field common to them, which is the supplier ID, and that's the products that we want to deal with here are those with ID greater than 20. And P products greater than 20. I can choose to order. Let me see, maybe I will not need to order. Let me run my code. Wow, something is not right. SU left join. Products is greater than, product ID, sorry. Yeah, so let me run it. Very good. Now, okay, now let me order. Order by product ID. Yeah, to make our result set. Okay, fine, good. So now let me now erase this. Good. Now we have the product ID. It brings it no until it gets to 21 and then begins to correspond the records. It corresponds the records up to 45 where it has matched records. And where it has unmatched records, it just gives no values. But you notice that it gives us only values for those that are greater than 20, starting from 21. You can also run the code by writing the right join equivalent. Just copy this. And then this changes to right, just as I've been writing it. Change to right, and then we have a reversal of the right join suppliers. And then run it. Okay. As P and this as SU. Good. And then we run it. Yeah, and then it works. It gives us the same result set. 21, others as null, because we want the filter is a condition and at the same time a filter. We say on the condition that, okay, the product is greater than 20. That means for those below 20, you should just represent them as null. And then as from 21, it gives us a result set. So, but then if it is an inner join will leave out everything and will just give us 21 to 45. It will just, it wouldn't, if it's just an inner join with a where clause, it will just give us it will not give us the null values. So I hope I'm making sense at this point. If anyone is confused about anything, please feel free to voice out your confusion and then we are going to address it. So meanwhile, while we wait, if there are no questions, I'm going to just entertain just one more question because time is on our side. And that question will involve 3 tables. It's one major difficult aspect of writing joins when it involves more than 2 tables. Here we're going to, in our query, we want a result set that will give us all categories and suppliers' names, including categories without suppliers. All categories and suppliers' names, including categories without suppliers. Very good. Now, here, there is a very, very striking feature. And that feature is that we are talking about just 2 tables here. The categories table and the suppliers table. And yet we're talking about 3 tables. The problem here is we have a question that is very, very complex. Now, let me cut all of this out. Come in. Good. Now, this is the categories table. Let me open it directly from the schema. And this is the suppliers table. Good. So both tables, they have nothing in common. Unlike the products and the categories tables that have the product ID in common, the sales table and the salesperson's tables, they have the salesperson's ID in common. The products and the suppliers tables, they have the supplier ID field in common. But now the suppliers and the categories table, they have nothing, virtually nothing in common. We have a category ID, category name. None exists in the suppliers table. So how are we going to write a join now? So if we are told that, okay, what is needed here, what is required is a join. What we can do is to try to steer a middle course. Steer a middle course in the sense that we try to look at the database if we can find a table that is common to both tables that we are about to join. Now, the products table, fortunately for us, has a category ID that is in the categories table. And it also has a supplier ID that is in the suppliers table. On that basis, we can join both tables. And this is how we're going to do it. Please just follow me as I try to, solve this puzzle, because it's a puzzle. I call it a data analytical puzzle. So now, first is we need the category name. And I'm going to alias categories. The categories table here also has typo. Now, followed by the supplier's name. Supplier name. I'm going to alias suppliers as SU. And it keeps coming up. Just those 2. And now we want to include even categories without suppliers. That is, we need all information, all records about categories. Those that have suppliers and those that do not have suppliers. That means we are taking all records from the categories table, meaning that the categories table will have to be on the left when we use a left join, but it will be on the right if we use the right join to able to retrieve all records from the table. Now, we start with the categories. That has to be on the left so as to be able to return all records from the categories table. Categories are C. Remember, I said it has something in common with the products table, and that's the category ID. So we are going to join the categories table with the products table based on that field that is common to both of them. So now we have let's join products. The essence of products is just for us to be able to link the categories and the suppliers tables together on the basis of the category ID in the categories table. It equals the category ID in the products table. And then the second left join, remember our ultimate, target is the suppliers table. Suppliers as SU, which will also be joined based on where, remember, the suppliers table and then the products table, both of them, they have a supplier ID in common. On the condition that the supplier ID in the products table equals the supplier ID in the suppliers table. And then we run a code, execute it, and boom, we have a result set. We have a result set. Now, it is possible for us to still filter these results because it seems there are duplicates. So we can address that by just writing distinct. So the distinct keyword will help us to filter to avoid duplicates. And then we have, you see, we have here, yes. Now, we have information for categories that have suppliers. And if you look down here, the last three categories, cereals, vegetables, and pets, they do not have suppliers. No suppliers of them yet. So, because there are no suppliers, what we have there are null values. We can rewrite this as a right join. All we need to do is just to change using the right join equivalent. All we need to do is just to change the keywords left to right, and reverse the table order. Remember, when it is the right join, then the table from which we want to obtain all records move to the right because it's the right join. So that means categories has to come to the right. Categories will come down here to the right as C. P maintains its position. And then suppliers will go to the left. Suppliers as SU. And also because we have two conditions here for two right joins. Now we have suppliers and products up here. So that means the basis on which they have been joined must also be altered. So based on the supplier ID in the suppliers table, where it equals the supplier ID in the products table. And then right join. Finally, we have categories, products and categories. So that is where the category ID in the products table equals the category ID in the categories table. And then we now execute our code, and then we have the same result set. We have the same result set. Remember, I highlighted earlier that cereals, vegetables, and pets, they have no suppliers yet. As a result, what they are represented by null values. So that is how we can actually use a join to, join two tables, cancel, to join two tables that are not related in a database. If we are lucky to get a table in that database that is related to both tables simultaneously at the same time, on the basis of that table, we can join the two tables together. The essence of the product table here, I stress, is that it has joined the categories and the suppliers tables together on the basis of the common fields that it has with them, that it shares with them, that makes connections with those tables. I don't know if there are any questions at this point before I sum up this presentation. It's been intense. It's a lot to take in. It's becoming more complex, but then it's just tricky. This is what it is. It's not difficult to solve.
No, there's no questions here in the
Okay.
chat.
Okay. 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 So if there are no questions, it's been, 1 whole hour of discussing SQL outer joins. And so far, we have been able to establish the fact that the left and right outer joins, they exceed the limits of inner joins. They facilitate more complex data analytical operations that requires returning both matched and unmatched records. Just as Precious asked, she was kind of confused that why don't we just use inner? Why left join? Why right join? The reason is that the inner join will only return, as you have used that word, intersecting values, but the left and the right join will return all records from a particular table and just match the records, giving the value of matched records from the other table, and also representing the unmatched records with no values. So that is what the left and right outer join does. And the relations of reversibility between the left join and the right join offers more than one way of retrieving unmatched records from the database. Time is already, we don't have the time to do, to demonstrate further. Yeah, it's established that when left and right outer joins, when they return unmatched records, they return them as null values, but they return them as null values if they are string or what we call text. But if what is involved is numerical data, it will definitely return a numerical null value of 0. So that is what this summary is trying to point out. And I hope that maybe in subsequent sessions, we'll have more time to deliberate more on this aspect of left and right joins. But for today, I think we have had a swell time together. Thank you, Alex. Thank you, Precious, for the very insightful questions. They were useful for us to stay the course of today's presentation. And thank you so much, Margaret, for this opportunity of this session. It's very engaging, very interactive, and I hope we'll do more sessions very soon.
Oh, we actually have one more question. Well, thank you very much, Bukola, for.
Okay, we can still, if there's one more question, I can just take that if we have the time.
If that's okay, everybody, if you don't mind. So, Precious, would you like to ask a question?
Okay, sorry, just a quick one. Apologies for your time, everyone. I wanted to know, is this a repetitive thing whereby we meet every Tuesday? Because this is my first time joining. So is this something we do every Tuesday, or how is this schedule like? Because I would like to attend this on a regular basis. Thank you.
Oh, thank you. So basically, this is a group that we have on LinkedIn and on Meetup. And the days that I tend to schedule it is on Tuesday evening. We're not doing it every Tuesday, but I try to do it at least one Tuesday a month. Okay. In August, we might take a little break. But but I try to do every Tuesday. So we're doing different sessions and everybody can join. So in this, our group is people that are working in data or people that want to work in data. So the whole idea is that I like people to share their knowledge. So Bukola has been very kind. She prepared this presentation for everybody to kind of share her knowledge on SQL so that those who also want to improve their SQL can improve their coding. Also, those who want to improve their presentation skills, they can also use this as an opportunity to present something that they've learned, whether it be SQL, Power BI, data analytics, whatever it is that you've learned that is useful for a data analyst professional. Please feel free to share it. So you'll see that in the chat, I've actually put a link to the LinkedIn group. So I'd advise you, if you're on LinkedIn, join the group. That's where we're going to share the information. Like I said, our speaker, Bukola, is very, very kind. What she's done, she's actually going to share the link to the database. So you can now try and write the code that she's done. And she's given some questions. You will see it's highlighted in red, where you can try and write the code yourself and, interrogate, write these queries on the database itself. So that will kind of test your understanding of what we learned with the joins. Oh, we've got a question again.
Okay.
Yes, Precious? Okay.
Sorry, that was all my question. I'm so sorry. I think my hand was just up. Sorry.
No worries. Well, thank you so much. Thank you very much, Precious, for your questions and for everybody else for your questions. We really appreciate it because we like people to ask questions so that we can ensure that whatever we're teaching, you're understanding. That's the whole point. This is the engaging part, so we can actually learn and create friendships. That's why, again, we have the LinkedIn group. So we can, if ever you're stuck, you can ask a question and hopefully somebody out there will answer any question that you have. So please check the chat. I've given the link to the LinkedIn group. Please continue to be on Meetup and check out for events. Like I said, we'll have more events coming soon. And Bukola, I hope again we'll see you soon, sharing some new stuff.
Definitely.
Python, do share. So thank you very much for for teaching us about the difference between inner and outer, and when we'd use outer and the different ways that we'll be using it. We really appreciate it. And thank you as well for sharing your data as well.
Pleasure.
We really appreciate it. So that's all for today, everybody. Thank you very much for joining, and until next time, take care.